Hi dear students, today we will discuss question and answers from CBSE science textbook from a chapter called Force and Laws of Motion. All of you go through this video. In this video all questions are discussed clearly. If you have any doubt and queries, please write a message in comment box. Thank you. All the best. Yes students, our topic is force and laws of motion. In the chapter we'll see the first question. Which of the following has more inertia? Inertia. What is the meaning of inertia? It's a tendency to continue in the present state. The tendency of an object to continue in its present state. If it is in rest, it continue to stay in rest. If it is in motion, it will continue in motion. That is inertia. Now, first one, a rubber ball and a stone of the same size. Rubber ball and stone of the same size, which one has the more inertia? Second one, a bicycle or a train, and a 5 rupee coin and a 1 rupee coin. Here we have three pairs of objects, and we have to find out the one which has more inertia, right? Now answer. Since inertia is dependent on the mass of the object, so inertia depends upon mass of the object. The object with the greater mass will hold greater inertia. That's true. It's a statement. We know that, we learned that inertia depends upon the mass of an object. Higher the mass, greater the inertia. Lesser the mass, lower the inertia. The following objects hold greater inertia because of their mass. Now let's see what of them. A stone. Between rubber ball and a stone has higher inertia since its mass is more than a rubber ball. Though they are same size, a stone has more mass than rubber ball. That's why its inertia is more. Right? Second one, train. Train has more inertia than bicycle. Since train mass is more than bicycle, its inertia is more. And third one, 5 rupee coin. 5 rupee coin and 1 rupee coin. Of course, 5 rupee coin, since its mass is more than 1 rupee coin. So my dear students, here we can understand that inertia is nothing but tendency of an object to continue in its present status, present situation. That is called inertia. If an object is already in rest, it continue to stay in rest. If object is in motion, it will stay in a motion. This is called inertia. Inertia depends upon the mass of an object, right? So here is our first question completed. Now let's see. In the following example, try to identify the number of times the velocity of the ball changes, right? A football player kicks a football to another player of his team who kicks the football towards the goal. Now you see here we have a situation of a football game. One player kicks the ball to the another player. In turn, another player who kicks the football towards the goal. Right? Now, the goalkeeper of the opposite team collects the football and kicks it towards a player of his own team. So third player involved here, goalkeeper of the opposite team. And now also identify the agent supplying the force in each case. That means in each case direction of ball is changed. When direction of ball changed, that means velocity changes as well as acceleration and momentum also changes. Now the question here is identify the agent supplying the force in each case. Who are supplying the force in each case? Here, three three players involved here. They diverted the direction of the ball here. Now we'll see the answer. The velocity of football changes four times. Four times. First two players to the goalkeeper again to his own teammate, right? Four times. First, when a football player kicks a football to another player. Second, when the player kicks the football to the goalkeeper. Two situations we have seen here. Next, third, when the goalkeeper stops the football. Yes, goalkeeper stops the football here. That is a third one. And fourth is when the goalkeeper kicks the football towards his team player. So here, four times the velocity of ball changes, the direction of the ball changes, an acceleration of ball changes, momentum also changes here four times. Agent supplying the force here is the first case is the first player, the second case is the second player, is the agent here, and third case is goalkeeper, and the fourth case is again goalkeeper. Here goalkeeper involved two things. First, it brings that to the rest, then he passes that ball towards his own teammate. So here, four times the direction of ball changes, an acceleration of ball changes, velocity changes, everything changes. Right? We'll see. Explain why some of the leaves may get detached from a tree if we vigorously shake its branch. Here the question is, if you vigorously shake the branch of any tree, some of the leaves may get detached. That means they may fall down on the ground. If it is winter season, spring season, no need of shaking anything, but automatically leaves from the plant they fall down on the ground. But here the situation we have, if you shake the branch of any tree, few leaves they may fall down. That is the question, why they fall down. Your answer is, when the branch of the tree is shaken, the branch moves in a to and fro motion, vibrational motion, front and back motion. However, the inertia of the leaves in attached to the church branch resist the motion of the branch. Now see, before shaking the branch, leaves are in rest. They are at rest. Okay. Due to law of inertia of rest, at rest, they have the tendency to stay in their rest position only. But all of a sudden there is a movement in a branch, then the time these some leaves they try to some of the leaves they try to resist the motion of the branch. Therefore, the leaves that are weakly attached with petiole to the branch fall off due to inertia, whereas the leaves that are firmly attached to the branch remain attached. So this the inertia is the main reason for here. Generally, leaves they try to stay in their to continue in their rest position, and in that scenario, they resist the to and fro movement of a branch. The one which were attached to a branch weakly can be fall off due to inertia. Next question: why do you fall in the forward direction when a moving bus brakes to a stop? We have all of us have this experience, either in the bus or train or a own vehicle or a car, anything maybe. When brakes are applied to a vehicle, it stops here. Actually, brakes applies force in the opposite direction. and passengers just slightly bend in a forward direction. Brakes applied in backward direction, right? And the passengers they move forward direction and fall backwards when it accelerates from rest. When bus starts from its rest, then passengers will bend backward direction. When bus stops, passengers will fall forward direction. When bus starts, passengers will fall backward direction. Why? Here again, this no was inertia. Inertia is the reason for that. Law of inertia at rest, law of inertia in motion. These are the two things. According to that, this would happen. Now we'll see the answer. Initially, when the bus accelerates in a forward direction from a state of rest, the passengers experience a force exerted on them in the backward direction due to their inertia opposing the forward motion. Right. So passengers are in rest. They are in rest. Suddenly bus starts from the rest. So the body of passenger that resists the forward direction of a bus, that is called the law of inertia at rest. Right? That's why they bend backward direction. Once the bus starts moving, the passengers are in a state of motion in the forward direction along with the bus. When the brakes are applied, the bus moves towards a position of rest, right? Now, a force in the forward direction is applied on the passengers because their inertia resists the change in the motion of the bus. So, for these two situations, only one reason is inertia. Inertia. That means passengers are in rest at rest, but the passenger's body that like to continue in its rest position. Suddenly, when bus moves forward direction, it resists that forward direction. That's why it bends backside, and vice versa in the other case. Right? Next question. Yeah, last point. This causes the passengers to fall forward when the brakes are applied. Opposite forces acting here. Clear? We'll go to the next question. If action is always equal to the reaction, according to Newton's third law, explain how a horse can pull a cart. How a horse can pull a cart. That means only horse and cart are moving, but the road is not moving. How can we explain reaction which works on cart which is pulled by a horse? Answer: when the horse walks forward with a cart attached to it, it exerts a force in the backward direction on the earth. Backward direction on the earth. This you will easily understand when you walk in sand soil. We can easily push the sand backward direction. In turn, sand pushes us forward direction. But in on a road, we can't move the road in backward direction. But still, we move in forward direction. We'll see why. An equal force in the opposite direction, that is forward direction, is applied on the horse by the earth. That means though earth is not moving here, it applies some amount of net force in opposite direction or in forward direction on horse. That means it pushes horse to move forward direction. This force moves the horse and the cart forward. As a result, the cart moves the cart moves forward direction. So here don't think that as road is not moving backward direction, it doesn't show any reaction over here, but it shows it exerts a force in forward direction on the horse. Clear that? Next question. Explain why is it difficult for a fireman to hold a hose which ejects large amount of water at a high velocity. It's very difficult to hold this no fireman hose because water comes from the hose with a high velocity, and these firemen we can see they struggle to hold it. They struggle. They have to use more energy to hold it properly. Why is it so? Here you have answer. When a fireman holds a hose which is ejecting large amount of water at a high velocity, then a reaction force is exerted on him by the ejecting water in the backward direction. The water that means no that applies force on fireman in backward direction. This is because Newton's third law of motion, as a result of the backward force, the stability of the fireman decreases. He feels very difficult to hold that hose. He needs to apply more force to it. Right? Here also Newton's third law is applied. Right? Next question. And hence it is difficult for him to remain stable while holding the hose. Next question. From a rifle of mass 4 kg, a bullet of mass 50 grams is fired with an initial velocity of 35 meters per second. Now, calculate the initial recoil velocity of the rifle. Yeah, the students, we have here data that is a rifle mass is given, it says a 4 kgs, a bullet mass is given as 50 grams, and when it is fired, the bullet moves out of the rifle with a velocity of 35 meters per second. It's a high speed. Now, calculate the initial recoil velocity of the rifle. We are given bullet velocity in forward direction. We have to calculate recoil velocity of the rifle in backward direction, right? Now, given data is the bullet's mass M1 is given as 50 grams. Bullet's mass to be taken as M1. Rifle's mass M2 as 4 kg. This we have to convert into grams, that is 4000 grams. Why? Since bullet's mass is given in grams, we have to take rifle's mass also in grams. So that is equal to 4000 grams. Initial velocity of the fire bullet V1, that is equal to 35 meters per second. 35 meters per second. Initial velocity of the bullet. Let the recoil velocity be V2, that is final velocity. V2. Whose velocity is this? It is a rifle's velocity, recoil velocity. Since the rifle was initially at rest, the initial momentum of the rifle is zero. It is rest. The total momentum of the rifle and bullet after firing. So momentum formula, we know that momentum P equal to mass of product of mass and velocity, right? P equal to mv. Here rifle momentum m1 v1 is the initial, and bullet after firing, that is m2 v2. The total momentum of the rifle and bullet after firing. Before firing, it's given bullet is given as 35 meters per second, and rifle is 0. But after movement, after firing, the total momentum of rifle as well as bullet is m1 v1 plus m2 v2. m1 v1 is the momentum of rifle, m2 v2 is the momentum of bullet. Now, as per the law of conservation of momentum, the total momentum of the rifle and the bullet after firing is zero, same as initial momentum. If you apply, if you substitute those values in this formula, m1 is given as 50, v1 is given as 35, plus m2 is given as 4000, and vt we have to find. Since it's a initial momentum is zero, and here the total momentum of the rifle and the bullet after firing is zero, same as initial momentum. See this here, this implies that v2 from this m1 v1 plus m2 v2 formula, we have to calculate v2 final velocity, v2 equal to minus m1 v1 by m2, minus 50 grams into 35 grams by 4000 grams. So that is equal to minus 0.4375 meter per second. It's very less. Here minus negative indicates that opposite direction, movement of rifle in backward direction, that is negative. Clear? Right, we'll move to two objects of masses 100 grams and 200 grams are moving along the same line and the direction with velocities 2 meters per second and 1 meter per second respectively. Students, here we have two objects. The mass of one object is 100 grams, a mass of another one is 200 grams. That means double the mass. And they are moving along the same line and direction with a velocity 2 meters per second. Object 1, velocity is 2 meters per second. Object 2 is 1 meter per second. Now, they collide, and after the collision, they collide with each other. After the collision, the first object moves at a velocity of 1.67 meters per second. Right? Now, determine the velocity of the second object. See here, these two objects are moving in the same line, one after another one. After traveling some distance, these two, the one which is moving faster hits the one which is moving slower. Then they depart, they collide, and after collision, the velocity of the first object increased. Velocity moves at first object, that is decreased, I think 1.67 meters per second. But determine the velocity of the second object. Answer: assuming that the first object is object A and the second is object B, it is given that mass of object A m1 100 grams, mass of object B m2 200 grams, initial velocity of A u1, it's given as 2 meters per second, initial velocity of B u2 is given as 1 meter per second, final velocity of A, that is v1, is given as 1.67 meters per second, and final velocity of B v2, that should be calculated, right? So the velocity of object A decreased from 2 meters per second to 1.67 meters per second. Total initial momentum, that is equal to initial momentum of A plus initial momentum of B. Momentum formula, we know that mass into velocity, right? P equal to m into v. Here m1 u1, initial momentum of A plus initial momentum of B, that is m2 u2. Here m1 is 100 grams and u1 is 2 meters per second plus m2 is 200 grams, u2 is 1 meters per second. So 200 grams meter per second plus 200 grams meters per second. Finally, you will get 400 grams meters per second. 400 grams meter per second will get it. This is total initial momentum, total for both objects. Now, as per the law of conservation of momentum, the total momentum before collision must be equal to the total momentum after collision or post collision, right? So before collision, before for initial momentum, it's 400 grams meter per second. So say after collision also, the momentum should be same according to law of conservation of momentum. Therefore, you see here, therefore, the first one is 400 grams meters per second. Solving for V2, for V2, 100 into 1.67 meters per second plus 200 grams V2, that is equal to 400 grams. That should be equal to 400 grams. Therefore, V2 equal to total initial momentum minus 1.67 1.67 upon 200 upon 200, that is equal to the meter per second. So that is the answer for this question. Now V2 is given as 1.165. 1.165. Final velocity of B 1.165. Initial velocity of B, that is 1 meter. So the initial velocity of object is decreased from 2 meters per second to 1.67 meters per second, but the final velocity of V2 increased from 1 meter per second to the 1.165 meter per second. Therefore, the velocity of object B after the collision is 1.165 meters per second. So this is the velocity of the second object. Here we have to use law of conservation of momentum. We have to calculate total initial momentum. From that we have to find out final velocity of object 2 using this formula m1 u1 plus m2 u2, that is equal to m1 v1 plus m2 v2. Final momentum, initial momentum should be equal to the final momentum of objects, that is equal to 400 meters per second. You got it? Now, next question. An object experiences a net zero external unbalanced force. Now see children, when an external unbalanced force acts on an object, right? Unbalanced force on object, it moves on the opposite direction. But here an object experiences a net zero external unbalanced force. That means there is no unbalanced force on it. Is it possible for the object to be traveling with a non-zero velocity? See, when a balanced, no, it's a net zero external double unbalanced force. When there is a balanced force acting on an object, object will be in rest. That continue in rest. If object already in motion, that will continue in motion. If yes, state the conditions that must be placed on the magnitude and direction of the velocity. If no, provide a reason. This is the question. See here, object is experiencing a net zero external unbalanced force. No unbalanced force is working on it. Now will the answer? Yes, it's possible. An object moving in some direction with constant velocity will continue in its state of motion as long as there are no external unbalanced forces acting on it. That's what we discussed. If object is already in rest, if there is no unbalanced force acting on it, that object continue to be in rest. If object is already in motion, if no unbalanced force acting on it, it continue in its motion. That's what we have discussed, we have learned. In order to change the motion of the object, some external unbalanced force must act upon it. Yes. If you want to bring the object which is in rest to in motion, you need to apply some unbalanced, external unbalanced force on it. If you want to stop an object which is already in motion, we have to apply some external unbalanced force. If you want to increase the velocity of an object which is already in motion, here also we have to apply some unbalanced external force on it. Clear? Right. When a carpet is beaten with a stick, carpet is beaten with a stick, dust comes out of it. Dust comes out of it. Right? It's a very regular practice in our home. We can see our moms or maids they clean the carpets by right beating the carpet with a stick. That time we can see some dust particles they fly, they come out of the carpet. Why? We have to give reason here. Your answer? When the carpet is beaten with a stick, the stick exerts a force on the carpet which sets it in motion. Right. We're transferring our force or energy to the stick, thereby stick transfers that same energy to that mat or carpet, whatever it is there. Then that exerted force on the carpet that sets that is in motion, carpet in motion. The inertia of the dust particles residing on the carpet resist the change in the motion of the carpet. Now you see here there are some dust particles. Those dust particles already in at rest in carpet. But all of a sudden we brought some change in the movement of carpet. That time these particles they resist the movement of carpet in that process, and all particles they move, they come out of the carpet. This is a law of inertia at rest. Therefore the forward motion of the carpet exerts a backward force on the dust particles, setting them in motion in the opposite direction. So the forward motion of the carpet exerts a backward force on the dust particles, setting them in motion in the opposite direction. That's why dust particles they come out of carpet when it is beaten with a stick. This is why the dust comes out of the carpet when it is beaten with stick. Right? Now, why is it advised to tie any luggage kept on the roof of a bus with a rope, with a rope? Right? We saw many times while going different places or native places, we can see many people they just put their luggage on the top of the bus and they tie with a rope. Why? If you don't tie with a rope, will they fall down or are they safe on the roof? If it is so, why? If not so, why? That's the reason we have to give here. Your answer: when some luggage is placed on the roof of a bus which is initially at rest, the acceleration of the bus in the forward direction will exert a force in the backward direction on the luggage. Right? Actually, initially luggage is in rest, but suddenly bus starts their forward direction. When bus moves forward direction, that exerts force on the luggage, in the backward direction. That means what? When as bus moves forward direction, luggage moves backward direction, they fall down. To avoid them falling down from the roof of the bus, we have to tie with a rope, right? In a similar manner, when a bus which is initially in a state of motion suddenly comes to rest to the application of brakes, that means it shows the force in backward direction. When it bus shows backward direction, it exerts pressure on the luggage in the forward direction. A force is exerted on the luggage in for opposite direction. Depending on the mass of the luggage, the magnitude of the force, the luggage may fall off the bus due to inertia. Inertia due to inertia. It's a inertia of thrust, inertia of motion. Tying up the luggage will secure its position and prevent it from falling off the bus. So the main reason, the main reason beyond this one is inertia, inertia of rest, inertia of motion of an object. That's why we have to tie the luggage which is kept on the roof of the bus. Clear? Now we'll go to next question. It's a big question here. It has a four subparts over here. We'll see that. A batsman hits a cricket ball which then rolls on a level ground. After covering a short distance, the ball comes to rest, right? And the ball slows to a stop because after rolling some distance, if no failure is there, after traveling some distance, ball comes to a rest. Why? They're asking, giving different questions here. The ball slows to a stop because the batsman did not hit the ball hard enough. What is the reason for that? Or velocity is proportional to the force exerted on the ball, or there is a force on the ball opposing the motion. There is no unbalanced force on the ball, so the ball would want to come to rest. What is the correct option here? Right? Pause the video and think about it. Right? Now let's see the answer. When the ball rolls on the flat surface of the ground, its motion is opposed by the force of friction. Right? Always force of friction always works in opposite direction of object's motion. The friction arises between the ground and the ball, right? This frictional force eventually stops the ball. Therefore, the correct answer is C. What is the correct answer? There is a force on the ball opposing the motion. That force is called frictional force, right? If the surface of the level ground is lubricated, that means smooth surface, lubricated with oil or some other lubricants, the friction that arises between the ball and the ground will reduce, which will enable the ball to roll for a longer distance, right? But here the ground or the pitch is not smooth surface. Here we can see some soil and some grass growing on it. So this rough surface provides more friction against the ball. That's why ball will not travel more distance here. So this is the exact reason for that one. So option C is the correct one. There is a force. That force is nothing but friction force on the ball opposing the motion of the ball, and that comes to the rest after traveling some distance. Now the next, a truck starts from rest. Truck, a vehicle starts from rest and rolls down a hill with a constant acceleration. It's rolling. It's rolling from higher altitude to a lower altitude. A constant acceleration being maintained here. It travels a distance of 400 meters in 20 seconds. The distance from higher altitude to the lower altitude is given as 400 meters, that covers the distance with constant acceleration in 20 seconds. Now we have to find its acceleration, find the force acting on it if its mass is 7 tons. 7 tons. Here we have hint also, 1 ton is equal to 1000 kilograms. 7 tons means 7000 kilograms. Right? This is our question. We have to find its acceleration and we have to find the force also. Magnitude of the force we have to calculate. Now the answer is, given data, the distance covered by the truck S equal to 400 meters. Time taken to cover the distance T is given 20 seconds. 20 seconds. Then what is the speed of here? Distance upon time. 20 by 400 by 20, and it's 20 meters per second. It's a speed. The initial velocity of the truck is 0 u, since it starts from the rest. It's mentioned in the question, right? Now from the equations of motion, second second equation of the motion, that is s equal to ut plus half at square. Here initial velocity is given as 0, time is given as 20 seconds, and acceleration that we have to calculate, again time 20 seconds over here. Now if you substitute all the values in equation called ut plus half a into t square, and therefore you will get total 400 meters distance equal to initial velocity 0, time 20 seconds, plus half into a into 400 seconds square. 400 a t square, a t square, a t square, 20 square, that means 400. If you substitute all values here, finally you will left with 2 meters per second square. 2 meters per second square, right? A equal to 2 meters per second square. Now the acceleration of the truck is equal to 2 meters per second square. That means for every meter it is consuming certain time. As per the second law of motion, force equal to mass into acceleration, F equal to ma. Now first we have calculated acceleration of the truck. It is given as 2 meters per second square, and part B will see that mass of that force that acts on the truck, that by using second law of motion, that is force equal to mass into acceleration. Now mass of the truck is given as 7,000 kgs. If you substitute this value here, acceleration already we have calculated. Now force equal to mass 7,000 kgs, and acceleration is 2 meters per second square. That gives you 14,000 kg meter per second square. That gives you 14,000 newtons. So 1 newton is equal to 1 kg per 1 kg times meter per second square. So total 14,000 of newtons of force should be acted on the track to cover the distance of 400 meters here. Therefore, a force of 14,000 newtons is acting on the track. Right? Next question. A stone of 1 kg is thrown with a velocity of 20 meters per second across the frozen surface of a lake and comes to rest after traveling a distance of 50 meters. What is the force of friction between the stone and the ice? Here is the situation. There is a lake. In that lake, water is frozen and it becomes hard substance. Now a stone 1 kg is taken. It is thrown across the lake. That thrown stone traveled with the velocity of 20 meters per second, right? And comes to rest after traveling a distance of 50 meters per second. A stone of mass moving with a 20 meters per second velocity covered 50 meters of distance after some time. What is the force of friction between the stone and the ice? Right? Now let's see the data. Given data is mass of the stone is given as 1 kg. Initial velocity is given as 20 meters per second. Final velocity v is 0 meters per second since it comes to the rest. Distance traveled by the stone s equal to 50 meters. As per the third equation of motion, v square equal to u square plus 2as. Substituting the values in the above equation. So choosing correct formula is very important. Here time is not given. If you observe in the question, time is not mentioned. So in first equation of motion, time is mentioned, that is v equal to u plus at. At second one, ut plus half at square, time is mentioned. But in the third equation, v square equal to u square plus 2as, or 2as equal to v square minus u square. There is no mentioning of time. So we have to calculate, we have to choose this formula. So v square, it is a rest, right? It's given as a 0 square, that is equal to u square 20 meters per second, 20 square, plus 2 times of acceleration into distance 50 meters. Now 400, 20, 20 is 400, that is equal to 2a, 100 a, right? If you bring this side, that 400, that becomes minus 400, that is equal to 100 a. Now the acceleration a equal to minus 400 upon 100, that gives you minus 4 meters per second square. So here negative symbol minus 4 meters per second square, that gives you decrease in constant or uniform decrease in velocity, that is called retardation or deceleration. We know that F equal to me, law of Newton's second law of motion, second law of motion. Substituting above obtained values of a equal to minus 4 meters per second in the formula, second formula of Newton, we get F equal to mass, it is given as 1 kg, into, well, acceleration is given as minus 4 meters per second square, that gives you minus 4 newtons of force, acting on that stone to come to the rest, that is called frictional force, right? Here the negative sign indicates the opposing force, which is frictional force. So 4 newtons of friction force acting on a stone that is already moving with 20 meters per second and which is covered 50 meters, right? That experiences force of 4 newtons in opposite direction. Next question. Next question. An 8,000 kg engine. Here one engine is given, a train engine, whose weight also given, mass is also given, that is 8,000 kilograms, that pulls 5 wagons, right? Each wagon's mass is 2,000 kilograms is given along a horizontal track. If the engine exerts a force of 40,000 newtons, right? Exerts a force of 49,000 newtons and the track offers a frictional force of 5,000 newtons. Right. See here, an object, a train is moving here, and whose engine's mass is 8,000 kilograms, and that is pulling 5 wagons. Each wagon's mass is given as 2,000 kgs, and again That engine exerts almost 40,000 newtons of force on the five wagons, and same time some forces, friction forces acting on those total train or that wagons, which is given as 5,000 newtons. This is the information we have. Now we have to calculate the net accelerating force. Accelerating force we have to calculate, and second thing is the acceleration of the train. These are the two things we have to calculate from the given data. Now answer. Given data, the force exerted by the train F is given as 40,000 newtons. Force of the friction is given as minus 5,000 newtons because friction always works in opposite direction. So it is taken as minus 5,000 newtons. The negative sign indicates that the force is applied in the opposite direction. Therefore, the net accelerating force on the wagons, five wagons, is sum of all forces. Sum of all forces, that means the force exerted by engine and the force exerted frictional force. We have to take sum of all these two forces here. 40,000 newtons plus minus 5,000 newtons, it is 35,000 newtons. So this is the net force which is acting on wagons. 35,000 newtons of force. Second thing, total mass of the train, that means acceleration we have to calculate. Total mass of the train is given as mass of engine plus mass of each wagon. We know that mass of engine is 8,000 kgs and each wagon's weight is 2,000 kgs. Five wagons are there. 8,000 plus 10,000. That gives you total mass of the total train including wagons and engine. It says 18,000 kg mass. Total mass is 18,000 kgs. As per the second law of motion, so here we have force mass is given and force, how much force acting on it also given. So we have to calculate acceleration from the second law of motion, that is called F equal to ma. So from this we have to calculate acceleration. Acceleration is equal to force upon mass. Therefore acceleration of the train is equal to net accelerating force upon total mass of the train. So net accelerating force is 35,000 newtons upon 18,000 kgs of mass. That gives you around 1.94 meter per second square. Now the train which is moving with an acceleration of 1.94 meter per second square. The acceleration of the train is 1.94 meter per second square. See my dear students, here we have to consider both the forces which is acting on total train and one engine force which is 40,000 newtons and as well as a friction force which is 5,000 newtons. If you take it, if you sum this one, it gives you net force of 35,000 newtons. So from this data, we have to use Newton's second law of motion, F equal to ma, and from that we can calculate acceleration by the formula called A equal to F by M. So this is the answer for this one, right? Now children, we will see the next question. An automobile vehicle, it can be anything, any motorbike, a truck, a lorry, or a bus, or a car, or a jeep, or an auto, anything. It can be anything, and whose mass is given as 1500 kg. Now the question is, what must be the force between the vehicle and road if the vehicle is to be stopped with a negative acceleration? That means if you want to stop the vehicle with an acceleration, that means a retardation, deceleration of 1.7 meters per second square. what is the force that you have to apply on it? See, mass is given. We have to achieve the deceleration, that is 1.7 meter per second square in opposite direction. To achieve this deceleration or retardation or negative acceleration, what is the force that should we apply on the vehicle? This is the question. Now you see here, answer. Given data is like mass of the vehicle m is given as 1500 kg. Now acceleration a is given as negative 1.7 meter per second square. As per the second law of motion, see here mass is given, acceleration is given. So if you remember the law, Newton's second law, which has F equal to ma. Now that is force. So three physical quantities are given here. One is mass is given, force and acceleration. Out of these three, force should be calculated. So if you consider these three physical quantities, what is the formula that we can choose here is Newton's second law of motion. That formula we have to choose, that is equal to F equal to product of mass and acceleration. Now, if you substitute these values, mass and acceleration, in F equal to ma formula, so in place of mass we say 1500 kgs, in place of acceleration negative 1.7 meter per second square. If you multiply it, you will get a negative 2550 newtons. So our aim is we have to bring that object or vehicle to a rest position, maintaining a deceleration of 1.7 meter per second square, right? We have to, our aim is to attain that acceleration. To attain that acceleration, what is the force that we have to apply, right? So now the force which we have to apply here is 2515 newtons. Hence, the force between the automobile and the road is negative 2550 newtons in the opposite direction of the automobile's motion. Opposite direction, right? This is the way. So here we have mass is given, acceleration is given, and force to be calculated. When you just recollect these physical quantities, we have to immediately remember that Newton's second law of motion, that is a F equal to product of mass and acceleration. Choosing formula is very, very, very important, right? We'll see next question. What is the momentum of an object of mass m moving with a velocity v? Very simple question it is. It's a momentum. There is an object whose mass is given as m, that is moving with velocity a, mass into velocity, right? Then we have to calculate momentum, third physical quantity. Here two physical quantities are given, mass is given, velocity is also given. Third physical quantity, momentum, we have to calculate from this data. Options are given here: mv whole square, mv square, half into mv square, mv. These are the options. We have to choose the correct answer here. Now we'll say answer. The momentum of an object is nothing but, if you define momentum, it is nothing but the product of its mass and its velocity. Mass and velocity, that is called momentum of an object. Momentum is equal to mass into velocity. So the correct answer is mv. M for mass, v for velocity. So the option D is correct here. Clear this one? Right. We'll move to the next question. Now, using a horizontal force of 200 newtons, 200 newtons force is given here. We intend to move a wooden cabinet across a floor at a constant velocity. For example, you have a wooden cabinet. You want to move across that cabinet across a floor at a constant velocity, whose force applied on that object wooden cabinet is given as 200 newtons. So constant velocity is a physical quantity, force is a physical quantity. Now third one, we have to find out what is the friction force that will be exerted on the cabinet. See, whenever you just move an object across the floor, definitely one more force act opposite to that one is frictional force. So in this case, objects is moving with a constant velocity, and the force which is used on that object to move on is given as 200 newtons. In this case, what is the friction force that works or that will be exerted on the wooden cabinet? So we have to understand question clearly first. We have to read the question 2 to 3 times, then we have to come to a conclusion. Then it is easy for us to pick up the right formula to solve this kind of problems, right? Now we will see the answer. Since the velocity of the cabinet is constant, we don't know what is that. It's a constant. There is no change in the velocity. Hence, its acceleration must be zero. No acceleration, no acceleration at all. Since it is constant velocity, what is the acceleration? Rate of change of velocity is called acceleration. But here object is moving with constant velocity. There is no chance of accelerated. So acceleration of that object is zero. Therefore, the effective force acting on it is also zero. Effective force. It won't any no force acting on it is zero. This implies that the magnitude of opposing frictional force is equal to the force exerted on the cabinet, which is 200 newtons. Since there is no change in its velocity, since it is moving in constant velocity, there is no effective force would work on it. So whatever the force which is acting on the cabinet already will be same or will be equal to the frictional force which is acting on the object in opposite direction. Clear? This condition, you have to see the condition. Object is moving with a constant velocity. If object is not moving with constant velocity, then the friction force will be different, right? This is the answer. Now, therefore, the total friction force is a negative 200 newtons. That means opposite direction. Frictional force always acts on an object in its opposite direction. Next question. It's a big question, just to focus here. According to the third law of motion, third law of motion. What is third law of motion here? Let's see. When we push an object, the object pushes back on us with an equal and opposite force. This is third law, right? Every action has an equal and opposite reaction, right? If the object is a massive truck, that means it's a big truck whose weight is around 2000 kilograms or sometimes 3000 kilograms also, which is parked along the roadside, right? It's a situation given here. It will probably not move, right? This is the situation. Now, a student justifies this by answering that the two opposite and equal forces cancel each other. So, by this situation, a student tries to explain the thing. Since this is answering that two opposite and equal forces cancel each other. It is not moving at all. It's not moving at all. It is on the roadside in its rest position. Now, comment on this logic and explain why the truck doesn't move. Okay. Generally, we think which is not engine is not put on our condition. Nobody is driving. That's why it's not moving. We may think, but there is a physics behind that one, logic behind that one that we'll see. Since the truck has a very high mass, the static friction between the road and the truck is high. Static friction, it's not a dynamic friction, static friction. that attracts truck towards the floor, towards the ground. That is also high. That means friction depends upon mass of an object. When pushing the truck with a small force, right? And pushing a truck with a small force, the frictional force cancels out the applied force and the truck does not move. So if you try to move the force pushing from the backside, it will not move because the frictional force which is acting on the truck that cancels the force that you applied on a truck to push it move. So it will not, it cancels that. That's why a truck will not move forward. This implies that the two forces are equal in magnitude but opposite in direction, right? These two forces are, what are the two forces? Static friction and what are the frictional force, and these two are equal, right? Since the person pushing the truck is not displaced when the truck does not move, right? This is the answer for this question. Let's move on to the next question here. Therefore, the logic student's logic is correct. He exactly guessed over there. The logic is correct. Two objects, each mass 1.5 kg. Here we have two objects are there. One object's mass is given as 1.5 kg, 1.5 kg, and they are, other also 1.5 kg. Both of them equal mass, but they are moving in the same straight line but in opposite directions. Same straight line but in the opposite direction. One is facing each other. This is the situation, right? Now, the velocity of each object is given as 2.5 meters per second. Both of them are moving with same velocity. Before the collision, during which they stick together, during which they stick together. Before they collide with each other, these two objects are moving with same velocity, that is 2.5 meters per second, but in opposite direction. Then they collide with each other, right? They collide with each other. Here the information is given about before collision. Now the question is, what will be the velocity of the combined after object after collision? What is after collision? What is after collision? That we have to think about. Answer: a given data, mass of the first object, it is given as 1.5 kg. Second object also 1.5 kg. Now, velocity of first object before collision is v1 2 meter per second square. Second square. Now, the velocity second 2.5 meters second velocity. The velocity of the second object which is moving in the opposite direction, that is v2, that is equal to negative 2.5 meter per second, because that's coming in opposite direction. We know that the total momentum before collision is equal to total momentum after collision, right? So whatever the velocity they move, whatever the mass they move, they should have same momentum, that should be equal before collision to the after collision. Now we'll see how it is. We have a formula that is called m1 v1. That means momentum of object 1, final momentum of object 1, that equal to um, final momentum of initial momentum of object, and these two, that sum of these two, right? If you take a m1 m2, that is given momentum of both the objects into velocity, that is the momentum. Here m1 is given as 1.5, v1 is given as velocity 1, velocity of object 1 is given as 2.5. Again, m2, object mass is 1.5, object's velocity is minus 2.5. Then finally you get 1.5 plus 1.5. V. That gives you 1.5 into 2.5, that gives you 3.75, minus again 1.5 minus 2.5 gives you again 3.75, that is equal to 1.5 plus 1.5, 3V, right? There V equal to 0. If you substitute the values, V equal to 0. 3 3.75 minus 3.75, that equal to 0. 0 by 3 equal to 0. Therefore, the velocity of the combined object after the collision is 0 meter per second. After combining, after collision, that should be velocity is 0, right? This is the answer for this question. Now we'll go to next. A hockey ball of mass 200 grams. Here a hockey ball is given whose mass is given as 200 grams, and that is traveling at 10 meters per second, right? 10 meters per second velocity, and it is struck by a hockey stick, so it so as to return it along its original path with a velocity of 5 meters per second. So a ball is traveling with 10 meters per second, but to bring that to the 5 meters per second velocity, it was struck by a bat, hockey stick. So this is the situation we have. Now calculate the magnitude of change of momentum occurred in the motion of the hockey ball by the force applied by the hockey stick. Now we have to calculate the magnitude of change of momentum after hitting with a hockey stick. Now we'll see the answer. Given data, mass of the ball m is given as 200 grams. Initial velocity of that ball u is given as 10 meter per second. Final velocity it is given as negative 5 meter per second, since it diverted in opposite direction, right? That means axis velocity decreased, that means it's a negative, right? Initial momentum of the ball, that is equal to initial momentum formula, mass into its velocity. Mass is given as 200 grams, that already we know, and initial velocity given as 10 meters per second. Then you will get 200 into 10, 2000 grams meter per second. 2000 grams meter per second. This is the initial momentum of the ball. Now we'll calculate final momentum of the ball. The final momentum of the ball, again we have momentum is equal to mv. Here mass is same 200 grams, but velocity, final velocity is, that is negative 5 meters per second. That gives you negative 10,000 grams meter per second. Now you see initial momentum is 2000 grams meter second. Final momentum is given as negative 1000 grams meter per second. Therefore, the change in momentum, that means momentum, final momentum minus initial momentum. Final momentum is minus 1000 grams meter per second, minus initial momentum is minus 2000 grams meter per second, and finally you will get minus 3000 grams meter per second, right? Opposite direction, right? This is the change in momentum, right? This implies that the momentum of the ball reduces by 1000 grams meter per second after being struck by the hockey stick, right? This is the answer we have. Next, a bullet of mass 10 grams. Now here we have different object, a bullet, a rifle bullet or gun bullet or revolver bullet. A bullet of mass 10 gram which is traveling horizontally straight with a velocity of 150 meter per second, right? Then it strikes a stationary wooden block and comes to rest in 0.03 second. Now calculate the distance of penetration of the bullet into the block. Calculate the distance of the penetration. That means how depth the bullet mm, pierces into the wooden block, right? That we have to calculate. Bullet mass is given and its velocity is given, and the time also given here. Mass, velocity, time, everything is given. Mass, velocity, time is given, right? Then what is the formula that we have to select here? Now calculate the magnitude of the force, right? Exerted by the wooden block on the bullet. So here initial velocity is taken as 150 meters per second. Final velocity, that is 0 meter per second, because object comes to rest. Time is given. Change in velocity per time is called acceleration. So already mass is given. They asked us to calculate force. So mass is given, acceleration we have to calculate. With that we have to calculate force. So we have to use Newton's second law of motion formula here. Given data, mass of the bullet M equal to 10 grams, that is 0.01 kg. We have to convert grams into kilograms. Initial velocity of the bullet, that is 150 meter per second. Now final velocity of the bullet v, that is 0 meter per second. 0 is not given here, but we have a clue in the question, that comes to the rest means it's 0 velocity. Time period is given as 0.03 second. Now to find the distance of penetration, that means how much distance traveled by a bullet into the wooden block. The acceleration of the bullet must be calculated by using the formula, right? Let the distance of the penetration be s. As per the first law of motion, v equal to u plus at. U plus at is given. V, that is final velocity, is 0. U is given as 150 meter per second. Acceleration that we have to find out, time is given as 0.03. Now you bring acceleration this side, then you will get 150 by 0.03, that will give you minus 5000 meter per second square. Second square, this is the acceleration of object. So we have already mass, that is 100 grams or 0.0 kg. Now we have acceleration, that is negative 5000 meter per second square. Now we will calculate the force exerted on this bullet, on the wooden block, on the bullet, right? Negative direction. Here we have to take third formula of law of motion, that is v square is equal to u square plus 2as. My dear children, listen here. We have to use two formulas. One formula, first law of motion, to calculate acceleration, and we have to use second one, third one, that to calculate distance traveled by. Here no time is required for this, for to calculate force. Here no time is required. So in first formula time is there. In second formula also we know that ut plus half at square, time is there. And third formula, there is no time mentioned, so we have to go for that one. Time is not required here actually. So v square, that is given 0 square, u square 150 square plus 2 into minus 5000 meter per second square times distance. Now you bring distance to this side. If you multiply that one, so 150 15 225, almost 2200, 2250 will come, and by 10,000, 2 into minus 5000, that finally you will get 2.25 meters. If you substitute the values, you will get 2.25 meters. So this is the distance traveled by bullet into wooden block. As per the second law of motion, here distance also we calculated, and third one force we have to calculate here. So we have mass, we have acceleration. So Newton's second law, F equal to mass into acceleration. So F equal to mass, it is given as 0.01 kg, and acceleration is given as negative 5000 meter per second square. And finally you will get minus 15 newtons. 1 newton is equal to 1 kg times meter per second square. So minus 50 newtons of force should be worked on a bullet by the wooden block in opposite direction. Clear? An object of mass 1 kg traveling in a straight line with a velocity 10 meters per second. An object is given here, its mass is given 1 kg, it is traveling in a straight line with a velocity of 10 meters per second, and it collides with and sticks to a stationary wooden block. After traveling certain distance with the velocity, it it collides the stationary wooden block and sticks there also. And the wooden block mass also given as 5 kg. 5 kg. So two objects are given here. One is object 1, that is second one is wooden block. Their mass also given. Then they both move off together in the same straight line. They move off together in the same straight line, right? Now, calculate the total momentum just before the impact and just after the impact. That means we have to calculate the momentum, total momentum, just that object touches the collides the stationary wooden block and immediately after collision of the wooden block, and also calculate the velocity of the combined object. We have to calculate both objects velocity also. Okay, it's a bit tricky, but if you read this question number of times, if you understand one by one, definitely you will get a idea, better idea which formula to be selected to solve this. Everything you will get it. Don't worry. I will see the answer. Given data, mass of the object 1 m1 is given as 1 kg. Mass of the block m2 is given as 5 kg. Initial velocity of the object 1, that is 10 meters per second. Initial velocity of the block, that is given as 0 because since it is in rest position. Mass of the resulting object, that means mass object 1, mass of object 2, that is given as 6 kg. 6 kg, that means object 1 is 1 kg, object 2 is 5 kg, total 6 kg of mass working over there. Now velocity of the resulting object, that means final velocity after collision, before collision, that is to be calculated. Now the total momentum before the collision, right, that is m1 u1, mass and velocity of object 1 plus mass and velocity of object 2. Before collision we have to take mass is given as 1 kg and object 1 velocity given as 10 meters per second, and second one plus m2 u2 is nothing but 0. M2 is 5, u2 is 0, 5 into 0 0. Now the total momentum before collision was 10 kilograms meter per second. Meter per second. Now as per the law of conservation of momentum, here we have to use law of conservation of momentum. The total momentum before the collision is equal to the total momentum after the collision, right? We know that very well. Therefore, the total momentum post the collision is also 10 kg meter per second. 10 kg meter per second, right? Now, mass of object 1 plus mass of object 2 into V. Momentum, total momentum we have to calculate. Momentum formula M into V. So here M means two object mass to be taken into V. M1 1 kg, M2 5 kgs, right? Like into velocity. What is the velocity given here? That is given as 10 kg meter per second. Therefore, final velocity that we have to find out, V equal to 10 kg meter per second upon 6 kg, 6 kg. That gives you 1.66 meter per second. Momentum will be equal before collision, after collision, but velocity is different, right? The resulting object moves with a velocity of 1.66 meter per second. This is the answer for this question. An object of mass 100 kg is accelerated uniformly from a velocity of 5 meter per second to 8 meter per second in 6 seconds. See, my dear children, here object is given, whose mass is given, whose initial velocity is given, that is uniform accelerated acceleration, and final velocity also given, and time also given here. Now calculate the initial and final momentum of the object. Initial and final momentum of the object, and also find the magnitude of the force exerted on the object. So momentum formula we have to use m1 v1 u1 plus m2 u2, that formula. Again force formula we have to use F equal to mass into acceleration. Now we'll see data. Mass of the object is 100 kgs. Initial velocity of object is 5 meter per second. Final velocity is 8 meter per second. It's already given. Now time period is given as 6 seconds. So we have mass, we have velocity difference, we have time. We have time. Change in velocity is called acceleration. So mass is given, acceleration is given, time is given. Mass, acceleration, time. Now initial momentum m into u. Mass is 100 kgs, initial velocity 500 meter per second. That gives you 500 kg times meter per second. Meter per second. So initial momentum. Now final momentum is given as m into v, that is equal to 100 kg into 8 meters per second. The final momentum is 800 kilograms times meter times second. Now acceleration we have to follow. Acceleration is equal to final momentum, initial momentum we already calculated. Acceleration equal to v minus u upon t. V is final velocity 8 meter per second minus initial velocity 5 meter per second upon time given 6 seconds meter per second square. That means it gives you 3 by 6 meter per second square, that is equal to 0.5 meter per second square. So the object accelerates at 0.5 meter per second square. This implies that the force acting on the object is equal to force equal to mass into acceleration. Mass is given as 100 kg, acceleration is given as 0.5 meter per second square, and for 100 into 0.5, 15 newtons of force to be applied on it, exerted on it. Therefore, a force of 50 newton is applied on the 100 kg object, which accelerates it by 0.5 meter per second. Right? This is the answer for this question. So the next, now next question. It's a big question, like it's like a paragraph. Don't worry about it. So if you read question twice or thrice, you will understand. Unless until you understand the question, don't try to solve the problem. Okay? If you understand the problem clearly, then you will select the better exact formula to solve this problem. So don't worry about the question. Here, Akhtar, Kiran, and Rahul, three students' names are given. These three were riding a motor car that was moving with a high velocity on an expressway on an expressway, right? They are moving with, they were riding a motor car. They are there. When an insect hit the white shield, it's very funny thing, right? Generally, vehicles they dash with each other, hit with each other. But for the first time, we are seeing there is an insect. It hit in the windshield, and got stuck on the windscreen. We know the windscreen of the car, motor car. So it hit it stuck on the windscreen. Akhtar and Kiran started pondering over the situation. Kiran suggested that the insect suffered a greater change in momentum as compared to the change in momentum of the motor car, because the change in the velocity of the insect was much more than that of the motorcycle. Because here masses are different, we have to consider masses of two objects also. One object is motor car, second object is an insect. Now, Akhtar said that since the motor car was moving with a larger velocity, it exerted a larger force on the insect. And as a result, the insect died. But Rahul, while putting an entirely new explanation, said that both the motor car and the insect experienced the same force and a change in their movement. Right? This is the situation. So Akhtar he is arguing that one, since a car has a mass and since it is moving with high velocity, it must have applied a large force on the insect. That's why insect was died. But here, who is this? Rahul, knowing the force of law of forces, and he just explained him that both motor car and insect experience the same force and same change in their momentum. How then here comment on these suggestions? In what way Rahul tried to explain Akhtar the situation that we have to see? As per the law of conservation of momentum, the total momentum before the collision between the insect and the car is equal to the total momentum after the collision. This we know very well. Therefore, the change in the momentum of the insect is much greater than the change in momentum of the car, since force is proportional to the mass. Force is proportional to the mass, right? Higher the mass, higher the force applies. Lesser the mass, lesser the force applied, right? Now, Akhtar's assumption is partially right. Since the mass of the car is very high, the force exerted on the insect during the collision is also very high. It's a partially right? Kiran's statement is false. The change in momentum of the insect and the motor car is equal by conservation of moment. Now, the velocity of insect changes accordingly due to its mass as it is very small compared to the motor car. Similarly, the velocity of the motor car is very insignificant because its mass is very large compared to the insect. Now, Rahul's statement is completely right, as per the third law of motion, the force exerted by the insect on the car is equal and opposite to the force exerted by the car on the insect. Here, in this situation, we have to apply Newton's third law. That means every action has an equal and opposite reaction. However, Rahul's suggestion that the change in the momentum is the same contradicts the law of conservation of momentum. So this is the answer for this question. So we have to think beyond that. We have to imagine the situation. We have to think it. We have to coordinate all possible logics right? Logic here. Then we have to answer this kind of questions. I think it's the last question here we have. How much momentum will a dumbbell of mass 10 kg? We know dumbbell, we can see in the gym, we use this dumbbell for a better biceps and all and muscle exercises. So whose mass is given, that is 10 kg. Now, is a 10 kg transferred to the floor if it falls from a height of 80 centimeter? Somebody is working with a dumbbell whose mass is 10 kg. I think he must be doing a biceps exercise. By mistake, he dropped the dumbbell from a height of 80 centimeter. Then the question is, what is the momentum of that dumbbell will transfer to the floor? What is the moment? That is the question. Take its downward acceleration to be as 10 meter per second square. Actually, it is a 9.8 meter per second square. Let us round it up as 10 meters per second square. Right? Now, answer. Given data, mass of the dumbbell is given as 10 kg. Distance covered is 80 centimeter that we have to convert into meters. That is 0.8 meters. Initial velocity, that is 0, since it is dropped from a position of rest. Acceleration A is given as 10 meter per second square. Final velocity that we have to find it out. Now, momentum of the dumbbell when it hits the ground is equal to product of mass and its velocity. Momentum formula, its mass and velocity. As per the third law of motion, that means motion, that is v square minus u square is equal to 2 into as. 2 into as is given there. Therefore, v square minus u square, u is given as 0, that equal to 2 into acceleration is given as 10 meters per second square, and distance is given as, height is given as 0.8 meter. If you substitute these all values, you will get 16 meters square per second square. 16 meters square per second square, you will get it. Then if you just simplify that one, that gives you 4 meter per second. The velocity with which it touches it transfer the momentum to the floor is 4 meter per second. Now, final velocity we calculated. Now we calculate with what momentum, or the momentum which transferred by the dumbbell to the floor is like this, that equal to momentum formula, mass into velocity, right? So 10 kilograms into 4 meter per second velocity, that gives you 40 kilograms times meter per second. This is the momentum that transferred by dumbbell to the floor before it after it falls to the floor from a height 8 centimeter. I think with this we have completed all questions, textual questions given in a textbook. I hope you all understood this one. I hope you all enjoyed this one. If you have any doubts and any clarification you require, and please comment in a description box. Thereby I will try to explain your doubts. So that's it guys. I hope you all enjoyed this one, and thank you for watching this one, and I wish you a better luck for upcoming exams. If you have any doubts and queries, please message to me in the description box. I'll try to clarify your doubts. Thank you for watching.